Yeah, it's December, the year 2021, and this just popped up in the news. Some black holes are anything but black, and we've found more than 75,000 of the brightest ones. Like, if you are able to use your common sense, you don't have to understand anything about how to put it, astrophysics or stuff like that. Just the whole title is a really big oxymoron. How can a black hole be bright in the first place? And I thought I'm gonna read a little bit and then we listen a few minutes or a few sentences to Walt Thornhill, because he knows probably more what he's talking about than I am. When the most massive stars die, they collapse to form some of the densest objects known in the universe, black holes. They are the darkest objects in the cosmos, as not even light can escape their incredibly strong gravity. Because of this, it is impossible to directly image black holes, making them mysterious and quite perplexing. But our new research has road tested a way to spot some of the most voracious black holes of all, making it easier to find them buried deep in the hearts of distant galaxies. Despite the name, not all black holes are black. While black holes come in many different sizes, the biggest ones are the centers of galaxies and are still growing in size. These supermassive black holes can have the mass of up to 1 billion suns. The black hole at the center of our own Milky Way galaxy is called Sagittarius A, whose discovery received the 2020 Nobel Prize in Physics, is fairly calm. But that isn't the case for all supermassive black holes. Remember lunchtide cycles? 12,000 years? Which is the wave which is hitting us right now. The galactic dust. If material such as gas, dust, or stars get close to a black hole, it gets sucked in by the enormous gravitational force as it falls towards the black hole. It heats up and becomes incredibly bright. The light produced by these bright black holes can span the entire electromagnetic spectrum. From X-rays to radio waves, another name for the bright black holes at the centers of galaxies, active galactic nuclei. This sounds much better. And plasmoid. They can shine trillions of times brighter than the sun and can sometimes even outshine all the stars in the galaxy. The brightest black holes, some AGNY, and then they spew out matter via a jet, which travels millions of kilometers through space and can be seen by radio telescopes. Others produce winds at the center of a galaxy capable of pushing any gas, the fuel needed for stars to form, out of the galaxy. So I would suggest that these are electromagnetic currents, and here we have a C pinch in the middle. But let's have a quick listen to Walt Thornhill about modern science. I will put a link down to this video. You really have to watch that video, because it's really important.
electron structure. Now, according to particle physics, an electron has no structure. It's a fundamental particle. But that's a mathematical concept which has no physical reality, because if you try to reduce an electron to a point particle and give it charge, you end up running into infinities. And of course, once you do that, the theory breaks down. Scientists have a way of getting around that these days. They call it renormalization, where when your theory breaks down, you open the window, see which way the wind's blowing, plug that into your equation and keep going. They do that repeatedly for theories about the sun. So, what's the situation today? And this is a statement by Martin Rees, the former Astronomer Royal and Fellow of the Royal Society, well-known figure. It's one of the few things I agree with that he has said. He asked the question, what causes gravity and mass? These questions still baffle all of us. Rather than the end of science being nigh, in other words, we're almost at a theory of everything, we are still near the beginning of the cosmic quest. And I agree with that. Also, Richard Feynman has said, there is no model of the theory of gravitation today other than the mathematical form. And this, I think, when you watch shows on television about the mysteries of modern science, it's all about mathematics. While I was flying over here from Australia, I watched a show by Morgan Freeman on the mysteries of the universe. And that just devolved into a show of mathematical equations that no one understood. And it ended up with some guy saying that reality is just mathematics. Well, this shows how far away we've moved from classical physics, experiment, observation, testing of ideas, and verification by experiment. So, mathematics isn't physics. The guy on the right in that picture is Peter Higgs. I call him the $15 billion man because I think that's what the Large Hadron Collider had cost up until a year or two ago. Just a moment while I get my screen to give me what I want on there. That's better. So the first step on the path to discovery is to find where we left the path and got lost. As I said, it happened a century ago. Now, pictures like this are the favorite media cliche for genius. Have you noticed? It's an illusion. Now, Peter Higgs, the whole reason for the Large Hadron Collider was to show the existence of a hypothetical particle called the Higgs boson, which was supposed to give all other particles, the ones that make up you and I, mass. That's the most incredible nonsense idea I've ever heard. The particles that make us up, we know have mass, and they contain energy. An atom bomb tells you that. You can see the energy released by those particles when they're messed around with.
Yeah. No, I really suggest you to watch this whole video. Maybe you have to watch it a few times. It's about an hour long. But if you compare, like, watching this video, like, let's say 3 times, which is about roughly 3 hours, and then compare to all the things what they teach you in school and what you come across in mainstream media, how much time you spend reading those and trying to make sense out of them. And I think it's really worth when you understand the impossibility of the consensus theory, or how to put it, like Newtonian science, because they just don't have any proof except some mathematical formulas which are not valid as proof to some degree, because if it doesn't match up with the things what we see, it might be wrong after all. Thanks. Bye.